Hello and welcome to today's lesson. Today we're going to be looking at the tangent ratio. So first of all, tangent ratios deal with right triangles. So I've drawn a couple of triangles here. And before we can go much further, I'm going to show you how we name the sides of the triangle. Now you probably already know that across from the right angle is the hypotenuse. Okay, so I'm going to label the hypotenuse on each of my two triangles. Now suppose in this triangle we were focused on this angle here. In fact, let's give it a name. We'll call it angle theta, using the Greek letter theta. Relative to this angle, if we go across from the angle that we're talking about, this side is called the opposite side. So if, say, in this triangle I was focused on this angle, say this is alpha, then the angle, or the side rather, that would be considered opposite is across from angle alpha, so it's this one down here. This would be the opposite side. The remaining side, which is touching the angle that we're working with, is referred to as the adjacent side. Okay, and that means this side over here would be the adjacent side. So that's how we name the sides of the triangle. Now I'm going to clear the screen and we're going to look at sort of ratios of these sides. Let's clear that off. And I'm going to copy in a little triangle here. Now, let me see. I'm going to take this little triangle here. Actually, let's just label a few things first. Let's say I was focused on this little angle here, and I knew this side was a length of 1, and this side was a length of 3. Now, I'm going to take this little triangle now, and let's say I took a copy of this, and let's see if I hit copy, I might be able to just paste that. Oh, let's see if I can move it. Okay, so there, I just made a copy of it, and I'm going to make an enlargement of it. So let's see if I can do that. There we go. So I've just made an enlargement of this same triangle over here. Let's say I put on the photocopy or something. And it's a little fuzzy here, but anyway, let's say I doubled this side. So this side is a length of 2. If I said to you, what is the length of this side here, you could probably say, well, if I look at the original triangle, this side here seems to be 3 times as big as that one over there. So I'd look at this one and say, if it's exactly the same shape, but not the same size, but everything should be to scale, that means this side over here should be 3 times as big as this side over here, which means you would predict that this is a length of 6. And you would be absolutely correct. Okay, now suppose, so I'm just going to clear off the screen now. Suppose I take a triangle. Let's see if I can get this to work here. So I take a triangle. Let's make it a little bit bigger. Okay, so let's take a little triangle here. Oops, didn't mean to do that. Okay, I'll just leave it. So I take a little triangle and I figured out this angle here is 30 degrees. Okay, so I drew a right triangle and I made sure this angle here is 30 degrees. And this, if I label my sides, okay, across from the right angle is the hypotenuse. Across from the 30 degrees is the opposite. And that means this is the adjacent side down here. If I looked at this length here, the opposite, divided by the adjacent side's length, okay, so opposite over adjacent, that ratio, then it doesn't matter how big I make this triangle. That ratio is always going to be the same. Whether I make a bigger version of this same triangle, as long as it's got the same shape, then this ratio should always be the same. this ratio is referred to as the tangent of the angle. Now in this case the angle is 30 degrees. So we would say the tangent of 30 degrees would be this length here divided by the adjacent length. And this is going to be true for any triangle that I draw, as long as it's a right triangle and we're talking about an angle of 30 degrees. Now, if I went ahead and I measured this out, so let's say back in the ancient days, I measured this length here, I actually got an actual number, and I measured this length here. Then I could put actual numbers in here, and I could figure out what this tangent of 30 degrees is. Now, I went ahead and looked it up. This is something you do on your calculator. Making sure your calculator is set up to degrees, you would put in tangent of 30, and then you should see 0.577. So, as long as we have any kind of triangle, so let me just redraw that. So let me just start with an absolutely fresh triangle. So somebody comes along and says, I'm going to draw this triangle here. So go draw it like this. And they make sure two things. They make sure that this is a right angle. And then they make sure that this angle here is 30 degrees. Then it doesn't matter how big or small I make this triangle, as long as it's 30 degrees, 90 degrees, then I know that this length here, whatever it is, divided by this length over here, is going to equal 0.577, because we looked up the tangent of 30 degrees. Okay? And it doesn't matter if I flip my triangle around and I orient it completely different. As long as it is opposite divided by adjacent and it's a 30-degree angle in a right triangle, then that ratio is 0.577. Now that's probably a good place to stop. So I'm going to stop there. We'll catch you later and we'll get some actual numerical examples.